Today we are talking about section 1.5. This section is all about like terms, so our goal today is to combine like terms. So you don't need to write any of these down. I just want to see if we can group these expressions. So if I just said group these expressions, how would you start grouping them? So what would you put together with 7x? So we had 7xy as an idea. I'm going to try to switch your idea a little bit. So you want to put x's and y's all together? Negative 2x, I'll agree with that. What is so special about the 7x and the negative 2x? They both have x's. Is there anything else that just has an x? 17x. Let's group those together. Good. Any questions why I put those together? They all just have an x. All right, let's see if we can put something together with 9y. Where? Oh, let's separate the y's and the y's to the thirds. Let's not put those together. So we have a 2y. Good. Let's put those together. Any other just y's? Okay, let's see if we can match something with the xy's. So we have a 7xy. We have a 4xy. We have a 20xy. We have a 1xy. When there's no variable, it's like having a 1. Good, so that was a pretty big group, right? Girls, do you guys have any questions? No. Okay. Here's some x squareds. Do we have any other x squareds we can put together? That's a y squared. Do you think x squareds and y squareds should go together? No. So I don't really see anything that goes with the x squareds. But here's a y to the third. Do we have another y to the third? Yep. And then the lonely y squared. So, real quick, take a look at those. Can anyone describe how we grouped them? No, you did not. How did we group those? We were looking at two things. The exponents and the variables. Good. That is exactly what we're talking about when we say like terms. So what do you think the expressions have to have in common to be like terms? Two things. Same variable, same exponent. I want you to write this definition in your notes. Like terms. These are terms with the same variable and the same exponents. They need both. So you can't combine x squareds and x's, and you can't combine x squareds and y squareds. They have to have the same variable. Remember, variable means a letter. So same letter, same exponent, which is a little number behind it. So same variable, same exponent if you want to be like terms. Make sure you get this in your notes. It's very important that you have the vocabulary term like terms, because we're talking about them all day. You need to know what they are. So like terms, again, terms with the same variable and the same exponents. Any questions on like terms? So I just want to take a look at this. You don't need to draw a bunch of pictures in your notes, but I am going to combine this fruit. So I have some oranges and I have some apples. Let's first try to change this into something that's a little more mathy. So how many oranges do I have in the front? 3. What's a variable we can use to describe oranges? O kind of looks like a 0. Let's pick another one. Maybe like an R. R for orange. Okay, so I'm going to call that a 3R. What do you want me to call these two apples?
2A.
2A. Very good. What do I have here? 1R. I'm just going to call it R. You could put a 1R if you want. And then I have another plus sign. What do I have here? 4A. And then I have a minus 2R. So I just changed apples and oranges into a mathematical expression. Kind of cool, right? Now, when I'm adding these, can I add apples and oranges? No. What do I add oranges with? Oranges. So the R's go with the R's. I have 3 oranges. I'm going to jump over the apples and add the other oranges. So what's 3 oranges plus 1 orange? 4 oranges, or 4R, and then I'm taking 2 of those away. So what's 4 minus 2? So I have 2 what? Oranges, or 2R. Do I make that like 2R squared, or since I subtracted, do I take the R's away? What do you think? No, they're still oranges, okay? I had 3, I added another one, I had 4, I subtracted 1, now I have 2. What are your questions about the oranges? Let's talk about the apples. I have 2 apples and 4 apples, so that is 6 apples. I'm still combining these with the oranges, so I'm going to put a plus sign, but now it's 6A. Now, do you think I can magically like squeeze these together and make some hybrid apple orange? No. A lot of students take this stuff too far. They would add these and make it like 8RA. Think back to the apples and oranges. Oranges stay oranges, apples stay apples. You can't make some magical fruit on the last step where you combine everything together, okay? Same exact thing when we're talking about variables. X's go with X's, Y's go with Y's. They don't magically come together and make some magical term at the very end. So keep apples with apples, oranges with oranges, X's with X's, Y's with Y's. Make sense? Sort of? Kind of? Okay. Let's see if we can make some rules. So I want you to write this down in your notes. So these are the rules for combining like terms. First, we have to make sure they're alike. To be alike, what do they have to have? Two things. They have to have the same variable, same exponent. So first we're going to group them by variable and exponent. So I'm going to use that by underlining. So I'm going to underline everything that has the same variable, same exponent. Now, with the apples and oranges, what did I do with the number in front? Like the 3 oranges and the 1 orange. How did I get that to be 4 oranges? What did I do with the numbers? Added them. Yeah, so you're going to add or subtract. Here's a vocabulary word for you, the coefficients. Coefficients are the numbers in front. And then the last step is you keep variables the same. If we're talking about apples and we add them together, we're still talking about apples. If we're talking about oranges and we put a bunch of oranges together, we're still talking about oranges. So don't change the variables. So we find out what's alike, add or subtract them, keep the variables the same. So for the first example, I have 2x plus 3x. So, start with the first term. 2x. Is there anything that's alike? Like 2x? 3x. Yeah, they both have x's, right? There's a plus sign in the middle. So I'm adding these two terms. What is 2x plus 3x? 5x. I added the coefficients. I brought the variable along for the ride. You don't change it. You don't make it an x squared. It just comes right along with it. Like 2 apples and 3 apples, you still have 5 apples. What are your questions on example 1? All right, here's example 2. So I have a negative x plus 9. X. Sorry. A little slow there. Negative 2x plus 9x. So are these like terms? Yes, I always underline them in the same way. Like if you have colored pencils, that works really great here, but I know a lot of you don't. So I'm going to use a squiggle this time. So everything with a squiggle gets combined. What is negative 2 plus 9? 7, and then the x just comes along for the ride. Now, I will tell you, you can't type this in your calculator, negative 2x plus 9x, but you can type in negative 2 plus 9, and then just remember that the x comes along with it. So you can still use a calculator on these even though you don't have an x button.
Well, either way, the x always will be there.
If you have x's in your original problem, yes.
Yeah, that's what I mean. Yeah.
Mm-hmm.
Okay. What if only one of them have x?
Then they're not like terms. We'll look at something like that. Her question was, what if they don't all have an x? That will happen, and then you just can't combine them, so you just like write them next to each other. We'll look at some where they're not like terms.
Okay.
All right, are these like terms? All of them?
Yeah.
Yeah, they're all y's. So I'm going to put, I'll do the little like a V under it this time. Show they're all going together. Then you can just add and subtract from left to right if you have more than 2 going on. So what is 4y minus 3y? 11y plus 10y is 21y. Anyone wondering why this is true? Questions? All right, here's the next one. I'm actually going to change this problem just slightly. I am going to change the last 2 terms.
Oh no.
Just y and just x. Okay, so write it just like that. Sorry. I realized earlier that I forgot to put ones where there's no coefficient, so we'll practice with this one. So we have 3xy plus 4x plus 5y plus 3xy plus x plus y. Just getting creative. Okay, let's just start at the beginning. You usually start with the term that has the most variables, so we'll go with this one. What combines with 3xy? The other 3xy. So let's focus on those. What's 3xy plus 3xy? 6xy. Very good. Any questions on the xy term? All right, let's just move right along. Let's do the x's. What is going to combine with the 4x? Just the x. If there is no if there's no coefficient in the front, do you guys remember from last year what it's like having? A 1. It's like having a 1 right there. So if you want to add the 1, great. If you just want to remember that it's a 1, that's fine too. So what is 4x plus 1x? 5x. Very good. And it's a positive, so I'm going to put a plus 5x. And then here I have 5y and y. What's 5y plus y? 6y. If you're wondering, like, well, what? It's because this is a 1y. Now, very common mistakes here. People don't know what the coefficient is, so they make it a 0. You can't make it a 0, okay? If it's a 0, then that's like having no y's at all. You just have 1y. So it's a 1y. 1x if there's no variable. Or sorry, if there's no coefficient. You need to keep the variable. The other common mistakes, some people, like I said, they go a little too far here. They want to make this like a magical 17xy combination. Don't go too far. You got to know when to stop. And you stop when you don't have any more like terms. None of these are alike, so you're done. The other thing is people forget the plus signs. If your term is positive, you put a plus sign. If it's negative, you put a minus sign or a plus a negative. Either one works for this class. Any questions how I got from here to here? Does anyone need more time with this one? Alright, moving right along. Here's some x's. So 10x plus 2x minus 12x. Alright, I'm just going to start in the beginning. 10x. What combines with the 10x? The 2x and the 12x. Good. So from left to right, what is 10x plus 2x? So I have 12x minus 12x. Now notice the sign in front of the term sticks with the term. So this was a minus 12x. When I rewrote it, I kept the minus with the 12x. Now I have 12 minus 12. What is 12 minus 12? 0. So I have 0x. If you stopped here and wrote 0x, that would be fine. But what is 0 times any number? 0. So the more correct answer is just 0. Because no matter what you put in for x, if you multiply it by a 0, you're going to get a 0. Any questions on this one? Alright, here's the next one. Again, I'm going to switch this up, so don't write it down just yet. We can write all but the last term. I'm just going to change the 5y to just being a y. Just another one where we practice no coefficient at all. Alright, where do I want to start on this one? 3x. Oh, the minus goes with which term? The 4y. So don't put it back here with the 8x. This is a plus 8x. So what is 3x plus 8x? 11x. Good. Now, we are taking away 4y, so that's like having a negative 4y. What are we adding to it? 1y. So you have negative, stays with the 4. What's negative 4y plus 1y? Negative 3y. So I'm going to put as a minus 3y. Now, some students have a really hard time grasping that a negative and a minus are the same thing. If you want to actually write this one as a plus negative 3y, that's your business, okay? I will accept either one of these. Some teachers won't. I can't speak for all your algebra teachers in the future, but for me, this is okay. What is not okay is to just totally forget that there was a negative or a minus at all. This is bad. Okay? What are your questions? Last example. You have the rest of your class time in here for homework. I don't know if you guys caught this earlier, but I did say we always want to start with where there's the most variables. which also takes into account exponents. So the highest exponent is where we want to start. So I'm going to put this one in the front. Does anyone combine with that? No, it's just the sad old 9x to the third. Then you just go down from there. So if I started with x to the third, next I would want to look at the x squareds. What's negative 9x squared plus 9x squared? 0x squared. So I'm going to put plus 0x squared. And then what about this guy right here? Plus 9x. There's nobody that's going to combine with him. Aww. Okay, real quick. What is 0 times anything? 0. So do I need the x squared part? No. You could just put plus 0. But is adding 0 changing anything either? No. So you actually don't even need to write that. You can just skip this guy altogether. Again, because multiplying by 0 gets rid of the variable, and adding 0 doesn't change anything. So really the only time you need to write the 0 is if it's the only thing you have left. If you're just adding a 0, it's not important. Let's wrap things up before we go to your homework. What are like terms? You need two things to be like terms. What do you need? Same variable, same exponent. Very good. And then how do you combine them?
By the same number, same letter.
Okay, so once we determine that they have the same letter, they're like terms, right? But what do we do with the number part? Yeah, add or subtract it. So whenever you are combining like terms, that means you're adding and subtracting the big number in the front. We call that the coefficient. Any questions before homework time? All right, I'm going to pass out your homework. It's worksheet 1.5. It is due at the beginning of class tomorrow.